We will use the same data now to find out mean deviation about mode. Mode is denoted by capital Z, which will be summation f times modulus of x minus mode divided by capital N. So first of all, we need to find out what is mode. Let me write mode is equal to L plus F1 minus F0 divided by 2 times F1 minus F0 minus F2. This whole thing multiplied by I. So for this, you need not require the cumulative frequency table. So I can change this. Let me copy from the previous, this one. I will just copy here instead of cumulative frequency. And we don't know whether this is mode or not. Let me delete that. And we will also have one more column for calculating this F times. And I will again copy this there. I'll again remove this 26.3. Now for this data, let us first calculate the mode, right? Modal class will be what? The class which has got the highest frequency. Modal class is 38 is the highest frequency. So therefore the modal class is 19.5 to 29.5. So then L is our lower limit, which is 19.5 plus, open the brackets, F1 is frequency of the modal class. Let me write, this is our F1, this is our F0, this is our F2. I can now substitute those values. 38 minus 18 divided by 2 times 38 is 76, minus 18 minus F2 is 20. The whole thing multiplied by I. What is I? I is the difference between 29.5 and 19.5. Class width, modal class width, which is 10. Multiply this by 10. So this will become now 19.5 plus the numerator is 20. 20 into 10 is 200 divided by denominator is 76 minus 38. 76 minus 38 is 38 only. So now let us calculate this. 200 divided by 38. The result I have to add with 19.5. We get 24.76. I'll make it 24.8. So our mode is 24.8. Let me substitute that here. 24.8. Here it is again 24.8. So we have to now calculate this x minus 24.8. I didn't write a column for x. Let me write a column for x. Here we'll have x. X is the middle value. Here it is 4.75. Here it is, what is that? I think it is the same, no? Whatever it was. Yeah, I think this one. Let me see if I can copy that here. Yes, I could copy that. I mean, because 9.5 and 19.5, the mid value is 14.5. So it's fine. So now we can proceed. 4.75 minus 24.8. It is negative 20.05, but I will write positive because of the absolute sign. Then 14.5 minus 24.8. It is 10.3. Then the next 0.3. Then the next 34.5 minus 24.8. We get 9.7. Then 19.7. Then 29.7. Now let us find out this, which is this value multiplied by the frequency. So 5 into 20.05, we get 100.25. Then the next 10.3 multiplied by 18, we get 185.4. Then the next 0.3 multiplied by 38, we get 11.4. Then 9.7 multiplied by 20, we get 194. Then 19.7 into 9, we get 177.3. Then 29.7 into 2, we get 59.4. Now let us add these values. 59.4 plus 177.3 plus 194 plus 11.4 plus 185.4 plus 100.25. We get 727.75. So once we have this value, we can calculate mean deviation about mode is equal to whatever value we got it, that is 727.75 divided by the total frequency, which is 92. We get 7.9. So therefore, coefficient of mean deviation about mode is equal to mean deviation about mode divided by mode. So if we calculate that, we get 0.32 again. So in case if you find the contents of this video to be useful to you, I request you to please like, share it with your friends, and also subscribe to my channel. Thank you.